Welcome to This Explainer. Today, we're unpacking a source that details a truly fascinating legal defense. Usually legal defenses rely on standard loopholes or procedural technicalities, but not this one. We're looking at a case involving a man named Dr. Chen Jingyuan, and his defense uses the hard mathematical laws of statistical physics and complex network science to completely deconstruct a legal accusation of causing public confusion.
So here's the core question we really need to dive into. Can one tiny retweet actually cause a massive societal avalanche? A man is essentially being accused of triggering a macroscopic event with a single microscopic social media post. The legal system tends to look at A happening right before B and just assumes A caused B. But does the actual science of virality support that? If you click retweet today and next week society is in an uproar, are you really the cause?
To figure that out, we're looking at source material that maps out a clash of two very different worlds. On one hand, you've got the legal system's extremely linear assumption, this idea that a single online action creates a direct line to massive offline chaos. But the scientific reality? It's way more complex. Complex networks don't just fall over like a neat row of dominoes. They require highly specific structural conditions for chaos to actually emerge. All right. Here's our roadmap for breaking down Dr. Chen Jingyuan's defense. We'll start with the single retweet trial, then dissect the anatomy of a viral post, explore the edge node defense, dive into sandpiles and phase transitions, and finally, evaluate the verdict of science versus law. Part 1, the single retweet trial. Let's look at the foundation of the legal argument. So, the prosecution is claiming a direct causal link between a literal zero interaction retweet and severe public disorder. In criminal law, you've got to prove an objective act, a statutory harm, a causal link between the two, and the ability to objectively attribute that result to the defendant. Simple enough, right? They point to the post, then they point to the chaos. But the scientific defense? They argue this causal chain is physically and mathematically broken. Let's see exactly how. Moving right along to Part 2, Anatomy of a Viral Post. Okay, to understand how a post actually spreads on a microscopic level, we need to look at the Galton-Watson branching process. It's this classic mathematical formula from the 19th century that network scientists use all the time today to predict whether a piece of information will go viral or instantly die out. Basically, it calculates the children each post produces. Meaning, if you post something, how many people see it and then actually decide to repost it themselves. The absolutely crucial thing here is the average branching number, or R0. If that number is less than 1, the system is in a subcritical state. Mathematically, the cascade is guaranteed to die out. It just stops. But if it's over 1, you hit a supercritical state, and suddenly, you might just have a massive viral explosion on your hands. Now let's apply this to the defendant's actual data. This account had fewer than 100 followers, mostly inactive zombie accounts, and essentially zero history of interaction. Because of that, the defense estimates an R0 of just 0.05. That is deeply, deeply subcritical.
So, what does an R0 of 0.05 actually mean in the real world? Well, it yields an expected total spread of roughly 1.05 retweets. That's it. The mathematical cascade dies almost the second it starts. There was absolutely no multi-layered cascade here. No viral explosion ever took place.
Which brings us to Part 3, the edge node defense.
If his post died instantly, how does a network actually break? Well, we have to zoom out of it and look at the structure. Social media is what we call a scale-free network. That means 99% of users are structurally isolated edge nodes just hanging out on the long tail of the distribution. Meanwhile, a tiny 1% of users are these massively connected hubs. Those hubs are the real structural skeleton of the whole thing. If you've ever posted something and gotten 0 likes, well, congratulations, science calls you an edge node. And the source material shows this defendant's account was firmly in that long tail category. Under 100 followers, mostly zombies, practically zero structural reach, you just can't trigger a system-wide alarm from an isolated, empty corner of the room. According to the Cohen threshold theory, which looks at network robustness, removing or activating an edge node has practically zero impact on the network's overall structure. The math literally proves you could randomly delete thousands of these edge nodes and the network wouldn't even flinch. A microscopic edge node just doesn't have the capacity to inflict a macroscopic wound on a scale-free network. All right, zooming all the way out to the macro level now. Part 4, sandpiles and phase transitions. To really understand how societal chaos erupts, we look at the theory of self-organized criticality. Just picture a sand pile. You keep adding sand grain by grain, and for a long time, nothing happens. But eventually, the pile reaches a critical steepness, and at that exact moment, one tiny grain triggers a massive avalanche. The prosecution is essentially saying, aha, the defendant is that single grain. But the scientific defense points out that it's the instability of the whole pile that causes the avalanche, not some intrinsic magical power of that final microscopic grain of sand.
And this ties right into the fluctuation dissipation theorem. It's an absolute bedrock principle of statistical physics. It basically proves that a system's macroscopic response to an outside disturbance depends entirely on its own internal instability. Throwing a tiny pebble into the ocean doesn't cause a tsunami, right? Not unless the ocean is already fundamentally unstable and on the verge of collapsing. The system's response is dictated by its own internal tension. So the defense argues the prosecution made a massive category error here. They're confusing a normal local fluctuation, the standard background noise of millions of people tweeting every day, with a phase transition, which is a massive structural reorganization of the whole system. You absolutely cannot mathematically blame a microscopic fluctuation for macro-level chaos unless you first prove the entire system was perfectly primed to explode.
Let's bring it all together. Part 5, the verdict. Science versus law.
When we map the legal terms directly onto scientific reality, the contrast is stark. The court assumes a completely linear path. Post-illicit equals chaos. But the rigid laws of complex networks show us that an individual edge node action is just a local fluctuation. To actually catalyze a system, you'd need to be a network hub, and plotting macro chaos is technically a phase transition. The physics just completely reject the prosecution's linear logic.
And the ultimate proof is right here in the numbers. Judicial guidelines explicitly state that for a social media post to be considered a severe crime, it needs 500 or more retweets. But we just saw the math with the Galton-Watson process. The expected spread for this account was about 1.05. That is a massive 500-fold gap between the legal threshold for a crime and the mathematical certainty of what this defendant could actually reach.
Which perfectly drives home the defense's core argument. Fluctuations are the background noise. Phase transitions are the system's response. A microscopic action, a mere background blip, simply cannot be blamed for a macroscopic collapse unless the system was already falling apart. To blame the edge node is to literally ignore the laws of physics. So it leaves us with a pretty profound final question. We live in an incredibly interconnected world that behaves exactly like the statistical physics models we've explored today. As our society operates more and more like these complex systems, are our modern laws actually equipped to handle the science of complex networks? Or are we going to keep trying to blame a single grain of sand for the instability of the entire mountain? Thanks for joining me on this explainer. I hope it gave you a totally new perspective on how our world works.